Unit 2, Dealing with Data and Uncertainty. The focus of Unit 2, Dealing with Data and Uncertainty, is to gain experience working with statistics and probability. You will also explore a variety of graphs, charts, and applications of both statistics and probability. Let's take a look at discussion forum question number 2. A certain disease occurs in 1% of the male population, and the test for it is 98% accurate. If a man tests positive, what is the chance that he truly has the disease? A, 2%, B, 33%, C, 50%, when in doubt, flip a coin, or D, 98%. Let's review the facts. The test is 98% accurate. What does that mean? If 100 males have the disease, the test will show it for only 98 of them, or you will have 98 true positives. This is referred to as the sensitivity of the test. If 100 males do not have the disease, the test will show that they do not have it for only 98 of them, or you will have 98 true negatives. This is referred to as the specificity of the test. Let's assume we have 10,000 males who are tested for the disease. Therefore, our sample size is 10,000. We know that the disease occurs in 1% of all males, so the total number of males with the disease out of the 10,000 is 100, which is 1% of 10,000. That leaves 9,900, 10,000 minus 100, who do not have the disease. We also know that only 98% of the males who have the disease will test positive. So in the chart, 98% of 100, or 98 males who have the disease will test positive. That means that 2% of the males, 2% of 100, or 2, who have the disease will test negative. 98% of those who do not have the disease will test negative. That means that 98% of 9,900, or 9,702, will test negative for the disease when they do not have the disease. This is a true negative. So 9,900 minus 9,702, or 198 who do not have the disease, will test positive for the disease. Completing the table, we have 98 plus 198, or 296, who test positive, and 2 plus 9,702, or 9,704, who test negative. Now back to the question. If a man tests positive for the disease, what is the chance he truly has the disease? 296 will test positive. Out of those, 98 have the disease. So 98 divided by 296 equals 0.3311, or 33.11%, or approximately 33%. The answer is choice B, 33%. Because the disease is rare, even with 98% accuracy, the chances of you actually having the disease, given you tested positive, are only about 1 in 3. At the end of Unit 2, students should be able to describe, analyze, and interpret statistical information such as graphs, tables, and summarized data to draw appropriate conclusions when presented with actual statistical studies. Determine probabilities and expected values and use them to assess risk and make informed decisions. And finally, analyze civic and/or societal issues and critique decisions using relevant mathematics.